Hi students, today we are going to learn graphs of polynomials.
Dear students, today we are going to learn how to plot graphs for quadratic polynomials. In general, whenever we consider the quadratic polynomials, it may form two zeros or one zero or no zeros. Okay, now let us try to understand them. First, consider the polynomial x square minus 2x minus 3. The x values are randomly taken from minus 2 to 3. X square is minus 2 whole square, that is minus 2 into minus 2, 4. Then minus 1 whole square, minus 1 into minus 1, that is 1. Then 0 square 0, 1 square 1, 2 square 4, and 3 square 9. Again, if you consider minus 2x is minus 2 into minus 2, 4, minus 2 into minus 1, 2, then 0, then minus 2 into 1, minus 2, then minus 2 into 2, minus 4, and minus 2 into 3, minus 6. Again, last one is minus 3, which is a constant, so we get minus 3 throughout. So it is irrespective of the value of x, so directly we get minus 3 only throughout. Then what we are going to get here, simply add the values. 4 plus 4 8, 8 minus 3 5, then 1 plus 2 3, 3 minus 3 0, then minus 3, then minus 5 plus 1 is minus 4, then again minus 3, then 0. So here you can observe that the points are minus 2 comma 5, then minus 1 comma 0, then 0 comma minus 3, then 1 comma minus 4, then 2 comma minus 3, then 3 comma 0. Okay, so what are the points we obtained here? Minus 2 5, minus 1 0, 0 minus 3, 1 minus 4, 2 minus 3, 3 0. Now try to plot graph for this. Now we consider a graph sheet here like this. Now what are the points here? Minus 2 5. So you can see that it is minus 2 5. Then the next one is minus 1 0, then 0 minus 3, then 1 minus 4, then 2 minus 3 again, and 3 0. Now simply if you plot a graph for this, it will be like this. You get a parabola, of course. You can see the parabola. Okay. Now you can see that 1 minus 1 comma 3 are the zeros of this graph. Minus 1 comma 3 are the zeros of this graph. Okay, here you can see the two zeros, right? We can see the two zeros separately here. This is what we have to understand. Okay, right. Now let us go for the next one. Now let us go for the next graph, that is x square minus 4x plus 4. Again, minus 2 whole square is 4, minus 1 whole square is 1, 0 square is 0, 1 square is 1, 2 square is 4, and 3 square is 9. Then minus 4x, minus 4 into minus 2, 8, minus 4 into minus 1, 4, then 0, then minus 4 into 1, minus 4, then minus 8, then minus 12. Of course 4 is a constant throughout, so it will be throughout 4 only. Now 4 plus 8, 12 plus 4, 16, then 9, then 4, then 1, 0, and 1. Here we can observe that the smallest value is 0 only, so no need of any negative values on y-axis, right? So we get it like minus 2 comma 16, then minus 1 comma 9, then 0 comma 4, then 1 comma 1, then 2 comma 0, and 3 comma 1, right? Now again just you can see that the points are minus 2 16, minus 1 9, 0 4, 1 1, 2 0, 3 1. Now try to plot graphs for this. Now actually we can use the same graph sheet or we can use a new one, right? Suppose here in this case I'm taking a new one so that there is no interruption for this. And now for this graph sheet mainly we can focus here, so we can see minus 1 comma 9 is the point, minus 1 comma 9, then 0 comma 4, then 1 comma 1, then 2 comma 0, then again 3 comma 1. Can you guess what will be the fourth point? It will be again 4 comma 4. Right, now first let us plot the graph and observe whether our expectation is correct or not. Now let us try to understand this. Just here the beauty is always this parabola is symmetric about this point. So you can observe that it is passing through the point 4 comma 4, and further you can say the next point will be again, where will it be? Just you can see this is the point 4 comma 4, and again the next point will be here. So without doing any calculation itself we can see. Okay, now what are the roots you observe? You can see that again here now you can see that it has two zeros, of course, no doubt, but both zeros are same. Here 2 comma 2 means the two zeros are real and equal. The two zeros are equal. Here you can see it is 2 comma 0 means the two zeros are 2 comma 2. The two zeros are equal in this case, right? This is the next one. Now let us go for one more graph. Meanwhile just we go for the table again. The third polynomial is x square minus 2x plus 2. As usual you can see it is 4 1 0 1 4, of course it is 4, and then it is 9, again 4, then minus 2 into 1 is 2, 0, then minus 2, then minus 4, then minus 6. Of course here the next one is again it is 2 throughout. Because this is a constant, it will be the same throughout. Now the y values are 10, then it is 5, then 3, then 1, then 2, again it is 5. Okay, now just observe what happens here. The points you can see, the points are minus 2 comma 10, minus 1 comma 5, 0 comma 3, 1 comma 1, 2 comma 2, and 3 comma 5. Of course here it is 0 square is 0, 0 plus 2 is 2 only. So the symmetry property again you can observe here. Somewhere something is missing. Minus 2 comma 10, then minus 1 comma 5, then 0 comma 2, then 1 comma 1, then 2 comma 2, then 3 comma 5. Again you can see one kind of symmetry here about that specific value. Now let us see how will be the points here, right? What are the points, do you remember here? They are minus 2 comma 10, then minus 1 comma 5, then 0 comma 3, then 1 comma 1, then again of course I think it is 0 comma 2, not 3. Right, let us remove this point. It is 0 comma 2, then again you can see it is 2 comma 2. Then you can go for I guess next point 3 comma 5, and what will be the next point? It will be 4 comma 10, of course, without seeing that, without doing the calculations itself, you can say, or you can go for a guess what will be the next point, of course. Now just see what happens. Again you can see you just join these points. Of course you have to join them by drawing a line. This is our graph. Now again you can see so we can see that it is not meeting x-axis. So no zeros means we have to understand that there are no real zeros for this, right? No zeros does not mean that it has no zeros at all. This polynomial has zeros obviously, but the zeros are not real zeros, right? This is the way in which we can go for this. Of course, on the other hand, you observe this. Suppose you are given any two zeros, like I am going for this, that two zeros are 3 and 4. Then what is their sum? Easily you can observe the sum is 4, and what is their product? 3 1 jar 3 is their product. Now just observe what happens. Then the polynomial is x square minus 4x plus 3. and the two zeros are 3 and 1, which you can observe here 3 comma 1. Like this, randomly every time you can go for -1 -2, then the sum will be -3 at the time, and the product is 2. Now you can see a polynomial which is formed like x square plus 3x plus 2. Here you observe the signs of sum and product, how are they written in the polynomial. So like this we can continue, like for example -4 4, then sum is clearly 0 and product is -16, right? Then what happens here, just you can see the polynomial. Okay, this is the way in which we can go for different types of polynomials. I hope all of you understood this, right? That's all for today.
Okay students, bye. See you in next session.